Introduction to hybrid electric vehicles. The hybrid electrical vehicle, we can have the content hybrid electric powertrains, series hybrid, parallel hybrid, power split hybrid, hybrid powertrain components, regenerative braking systems, hybrid powertrain controls, various driving cycles and road conditions, fuel economy, classification of HEVs based on powertrain, challenges in HEV design and realization. A hybrid electric vehicle is a vehicle in which propulsion energy is available from two or more kind of energy sources, and at least one of them can deliver electrical energy. That is, one is the electrical energy source. So there can be various types of hybrid electrical vehicles based on these sources. It can be petrol IC engine and battery, diesel IC engine and battery, IC engine, battery and fuel cell, then IC engine, battery and supercapacitor, battery and flywheel and IC engine, battery and battery hybrid with IC engine can be also there. Thus, there are two or more than two type of sources, especially it has IC engine based propulsion and electrical based energy source, that is one motor and the supply system. Hybrid electric vehicle system is a complex. It has at least two propulsion sources as we have discussed. Whereas in pure electrical vehicle, it has only one source of energy, that is a battery, or it may be a with fuel cell. In electric vehicle, propulsion is produced only by electric motor and there is no IC engine. And because of this removes the need of fuel injectors, complicated engine controllers and other peripherals. So electric vehicle, that is a pure electric vehicle, is more simpler than hybrid electric vehicle. There is an efficiency improvement in hybrid electrical vehicle compared to IC engine, but lower than the electric vehicle. So as compared to IC engine, always hybrid electrical vehicle are efficient. The overall efficiency will depend on the relative size of the IC engine and the electric propulsion motor used into the hybrid electric vehicle. Hybrid electric vehicles have achieved significant improvement in fuel economy over conventional vehicles, that is IC engine. The magnitude of improvement depend on hybrid electric powertrain capability and efficiency, and at what driving cycle the vehicle is used will decide the fuel economy over the conventional vehicles. Hybrid electric vehicle in the market are generally cleaner in terms of pollutant emissions such as NMHC, NOx, CO, that is carbon emissions, and particulate matters. Now this is compared with the IC engine vehicles, because IC engine vehicles will have emissions, rather hybrid electric vehicle will have very less emissions because electric motor is used for the propulsion in addition to the IC engine. So the contribution of IC engine is reduced. So it will be cleaner or clean source as compared to the pure IC engine. Hybrid electric vehicles are more expensive than the conventional vehicles as high voltage battery pack is required. Battery management system is required. There is electrical machines, power electronics, electric components, high voltage cables, regenerative braking systems. So all this add cost and weight of the hybrid electric vehicle. So overall, the hybrid electric system is more expensive than other conventional vehicles. In the conventional powertrain, it includes the engine, maybe gasoline, diesel or petrol engine, that is IC engine. The transmission system, which includes clutches, hydraulics and controllers, a drivetrain, that is the final drive for the two-wheeler drive or four-wheeler drive. The primary function of the powertrain is to produce a propulsive torque at driving wheels to meet driver's demand and vehicle system demands by means of regulating engine torque and transmission gear selection. IC engine is the energy converter to produce mechanical work output by converting fuel, chemical energy, and fuel tank is the energy storage. So it has the electrical energy as well as the mechanical IC engine energy. Hybrid electric powertrain. The hybrid electric powertrain interfaces, as we have discussed, two energy storages, electric and mechanical. Also, there is a battery pack. Significant negative torque can be produced by electric machines, that is generators, at the driving wheels to deaccelerate the vehicle, and that is the regenerative braking. The energy recovery depends on mechanical to electric conversion during the regenerative braking. IC engine on-off transmissions are also automatic in the hybrid electric powertrain. So mostly IC engine will be turned on or it will be turned off as there is the support of electric motor. So it is possible to turn off or turn on the engine whenever required and keeping the electric motor for the driving purpose. Here we can see the hybrid electric powertrain. The hybrid electric powertrain, we can see there is the motor or generator. Depending on that types, there can be induction motor, permanent magnet synchronous motor, SRM motor, that is a switch reluctance motor. So various types are available and any kind of motor can be used. As motor is the electric component, there is IC engine, that is the mechanical component that supplies the mechanical torque. So here is the fuel tank, that is a fuel source, and this is the IC engine that is coupled to the transmission. Now this motor will be supplied by the battery, that is the energy storage. It can be battery, ultra capacitor, or fuel cell. And then it will be given to the various topologies of the converter, that is the inverter and multi-level converters, or DC to DC or DC to AC converter, depending on the type of the motor used. Also, it will have various devices, conversion devices, that is MOSFET and IGBTs. The important thing into this hybrid electric vehicle is the control. It will have a hardware and software that includes the control. It may have microprocessor in it or microcontroller in it, a digital signal processing or FPGA system. And also it will include various softwares to control the speed, torque. It can be have VV, VF, FOC or DTC, that is the field oriented control and direct torque control. And it may have also neurophysics softwares. So this is the overview of hybrid electric powertrain. There are four main contributions to the hybrid electric vehicle fuel economy. As there is mechanical to electrical energy conversion is achieved, and this can be achieved by the regenerative braking. A coordinated operation of the hybrid powertrain and the brake system that attempts to use less friction brake in general. So here, whenever the braking system is applied, instead of going for the mechanical brakes that can apply and waste the energy in the friction, regenerative braking is the electrical braking where it will generate the electricity as well as it will apply the electrical braking. So this is one of the contribution of the hybrid electric vehicles into the fuel economy. The hybrid powertrain does this energy recuperation or recovery, and the brake system applies the friction brakes when it is required. Next, mechanically shutting off the engine to reduce energy losses. In hybrid electric vehicle, it is possible to turn off the engine automatically to achieve more efficiency or more energy. This is significant energy loss associated with engine rotation and pumping, especially idle condition. As when the engine is idle in conventional IC engine, conventional vehicle, it is not possible to turn off. But in hybrid vehicle system, it is possible to turn off the engine instead of keeping it idle, because in idle position it will have losses, especially the engine rotation and pumping. So switching off the engine automatically, and during that we can keep the electric mode on. That is, the motor will provide the propulsion during the idle or lower speed conditions. Shutting off the engine eliminate this energy loss. Hence, energy at very light load is less efficient. Sorry, the engine at very light load is less efficient. So engine can be used at very uh, higher loads. Hybrid powertrain uses its electric drive to provide the propulsion. Whole system efficiency is improved. Next, operating the engine more efficiently. This is a hybrid powertrain control function, as it can displace engine operating points by controlling engine speed or engine load or both. For example, Atkinson cycle technology, as seen in many hybrid electric vehicles, is also contributing to engine efficiency improvement in a hybrid electric vehicle. Reducing vehicle accessory load and road load also can achieve the fuel efficiency. Most of the hybrid vehicles in the markets have reduced the load by using active green shutter, more aerodynamic designs, and low rolling friction tires, and using lightweight materials. Active necessary load management also plays a part in reducing overall vehicle power consumptions. Here, we will discuss typical hybrid powertrain configurations. The hybrid vehicle can have a series hybrid configuration. The configuration is mainly based on how the IC engine is providing the power driving torque, or how the motor is providing the driving torque. Whether these both are operating in supportive at a time, or they are separately working, that will decide the series hybrid, parallel hybrid, and power split hybrid or series parallel hybrid. Here, a series hybrid powertrain is shown. In series hybrid, the propulsion is provided by the traction motor or motors. IC engine and generator are decoupled from the drivetrain. So very important in series hybrid, as we can see, the motor will provide the transmission, and IC engine is not directly or mechanically coupled to the wheels. IC engine mostly drive the generator, and the generator can supply the inverter to convert AC to DC, and it is given to the battery. And then again the battery can supply it to the motor, and then this motor can give the torque to the transmission and to the wheel. So always the torque is provided by the motors, and IC engine supports to this battery charging through a generator. Here we can see the schematic of series hybrid again. IC engine, then generator, then there is a converter system, then it can give supply to the battery. Again, from the battery, it can be inverted and given to the motor, and then motor is connected to the transmission. So no, IC engine is not connected to the transmission, but it is IC engine is connected to the generator and it is supplying, and it is connected via this motor. So always motor is connected to the transmission. The series hybrid is the simplest kind of hybrid electric vehicle. Its IC engine mechanical output is first converted into electricity using a generator as seen. The converted electricity either charges the battery or it can bypass the battery to propel the wheels via the same electric motor and mechanical transmission. Hence, it is an IC engine assisted or IC engine supported electrical vehicle. Series hybrid electric vehicle is called as IC engine assisted vehicle, which aims to extend the driving range of the vehicle. The advantages of series HEV is flexibility for locating the IC engine generator set due to the absence of clutches throughout the mechanical link. Simplicity of its drivetrain needs 3 propulsion devices, IC engine, generator, and the electric motor. So it is a simple one. Disadvantages: propulsion devices need to be sized for the maximum sustained power if the series hybrid electric vehicle is designed to climb a long grades. So size has to be maximized. On the other hand, when it is only needed to serve a short trips as commuting to work and shopping, the IC engine generator set can adopt a lower rating. So here the size will be decided as per the requirement. This is the example of a Chevrolet Volt series electric vehicle. The second powertrain is the parallel hybrid. Both the electric motor and the IC engine can contribute to the propulsion of the vehicle directly. So this is the difference. Earlier, only the electric motor can contribute to the propulsion directly or providing the mechanical input directly. But here, both motor and IC engine can propel, give propulsion directly. If the clutch is engaged, engine torque and the motor torque are additive, so they can add. In other words, they are parallel. Here we can see the block diagram of this parallel hybrid. This is the fuel of the IC engine. Now it is connected to the clutch or solid, and directly it is giving torque to the transmission and then to the wheels. Now this is the mechanical, that is IC engine mode. Also there is a battery, then it will given to the inverter, then it will give to the motor, and motor will also provide the torque and it will go to the transmission and then to the wheel. So it is possible to operate either by the IC engine mode, or it can also operate by the battery mode separately, or they can operate both and provide the torque which is additive to each other. So this is the parallel hybrid. Here we can see a detailed diagram. This is the IC engine with fuel tank. It is coupled to the mechanical link coupling. Also, there is a separate loop for the battery, then connected to suitable converters to the motor, and motor will also provide the driving torque, and because it is coupled to the mechanical coupling, and both can give the torque to the transmission. But they can be operated also separately. Only IC engine mode switching this off, only electric mode switching or turning off the IC engine. The parallel HEV allows both the IC engine and electric motor to deliver power in parallel to drive the wheels. Both the IC engine and electric motor are generally coupled to the drive shaft of the wheels via 2 clutches. The propulsion power may be supplied by IC engine alone, by the electric motor or both, as discussed earlier. Conceptually, it is inherently electric assisted or electric supported, as earlier series hybrid electric was the engine assisted. Here it is the electric assisted. IC engine for achieving lower emissions and fuel consumption. The electric motor can be used as generator to charge the battery by regenerative braking or absorbing power from the IC engine when the output is greater than the required to drive the wheels. Advantages of parallel HEV. Better than the series hybrid electric vehicle. Parallel hybrid needs only two propulsion devices, the IC engine and electric motor. The smaller IC engine and a smaller electric motor can be used to get the same performance until the battery is depleted or discharged. Even for long trip operation, only the IC engine needs to be rated for the maximum sustained power, while the electric motor may still be about half or lower rating. The examples of parallel hybrid are Toyota Prius plug-in, Chevy Volt, Honda Accord plug-in, Ford Fusion Energy SE. The third type is the power split hybrid. An engine and two electric machines are connected to a planetary gear set PGS through the carrier, the sun gear, and the ring gear. Power split hybrid is something between series hybrid and parallel hybrid, controlled by the fraction determined by the gear. It can be designed to achieve a better compromise for city and highway driving cycles than a series hybrid or a parallel hybrid. So it is well suitable for the highway driving, that is long driving, as well as the short city driving. In Prius and Ford Fusion hybrid, IC engine is connected to the carrier as the input to the transaxle. Traction motor, also known as motor B, is connected to the ring gear as the output of the transaxle, and the generator, known as motor A, is connected to the sun gear. So you can see the two motors are there. Here we can see the schematic diagram of this system, that is power split hybrid. A series hybrid becomes a series parallel hybrid by adding a mechanical connection between the two electric machines. So here, as discussed, this is a planetary gear. Now the engine is connected through this gearing system to the motor generator 2, and again it is a motor generator 1 to this inverter and connected by the battery pack. Here we can see the power flow along the parallel paths and power flow along the series paths, and that will particularly provide the series mode or parallel mode, that is the power split mode. So power flow along the parallel path, we can see that is the engine, then it will go to the shaft, or from the battery pack, then it will go to the motor 2, and it will again. So here engine is also providing the torque, and its motor is also providing the torque. In the series path, we can see here engine will give input to the motor generator, then that is engine will give input, or it will drive the generator, and generated input will be given to the inverter, and then this will give input to the motor, and motor will give input. So engine is not directly providing the torque, but it is supplying or it is producing the input to the generator and given to the motor, and it will work. So this is how the power split mode is either operated in series or parallel. The advantage of this architecture is that at low speeds, the powertrain behaves as a series hybrid, running the engine at the most efficient operating point. At high vehicle speed, the engine can transmit torque to the driving wheel, thus the powertrain becomes a parallel hybrid. The same is shown in this diagram, where engine can be directly connected to the wheels, or engine can, by opening this, that is suitable clutch. So here, engine can drive the generator, and then from this, it can supply to the generator can supply to the electric motor, and then it will give to the shaft or the drive train. This is the diagram again shown for the power split. So here you can see the IC engine with this fuel, it can give directly input to the wheels. This is the for the parallel mode. So this is the direct given by the IC engine, and at the same time battery will also give input to the motor generator, and then it will also give input to the transmission. So here fuel input to the IC engine, and IC engine is also given transmission in this way, and battery is also giving mechanical input in this way. So it is a parallel. Or for the series mode, the IC engine will not directly give mechanical input to the transmission, but IC engine will give input to here the split, and it will give input to the generator. Then generator will feed to the battery via this inverter, and then the battery will give input to the motor generator, that is the motor, and then it will have the final drive. So this is how it can work either in series or either in parallel mode as per the requirement. These are the examples of power split or series parallel hybrid, the Toyota Highlander hybrid and the Toyota Prius power splitter.